as it turns out, and this is kind of the subject of today, when I was trying to purchase certified reference material of the SARS-CoV-2 virus, I ran into a brick wall, and I found that there are no isolates available. To my knowledge, I have looked and looked and looked, and I've confirmed with other scientists, including Dr. Mikovits, who worked in virology, and there are no isolates available. There are kind of cocktails of dead cells that have been grown in bovine serum that they call a, quote, isolate, and they'll send you 0.5 milliliter of this liquid. But then in their own disclaimer, they will say this should never be used to make vaccines because the majority of the genetic material in this vial is actually human host cell material and bovine serum material. So there you go. It's not isolated.
And is this something that is that the usual procedure for a virus isolate? I mean, if there might be others like from measles or something that you could buy. Is that always the same?
Well, as a disclaimer, number one, I'm not a virologist, and we don't typically check for viruses in our lab. We're checking for microbiology and other molecules such as glyphosate. So there are others who know more than I do about the issue of virology. But from the research that I've done, I have enough science to know how to shop for certified reference materials, right? I know what standards are. I know what the descriptions are. I cannot find isolated materials on anything related to SARS-CoV-2, and even the materials for other things like measles, they are mixtures. From what I can see, they're all mixtures. So what I expect to see, frankly, is either a solid, which is a small powder of dried nanoparticles, and I have standards like that, or I expect to see a liquid with the standard in solution with a stated quantitation amount or concentration. So for example, when I buy a glyphosate standard, the glyphosate is typically 1,000 micrograms per milliliter. So it's mass over volume. And I know, and that's a high concentration, by the way. So I know that's what's in here. All of these standards that I can find are so-called isolates of COVID viruses. None of them offer any quantitation specifications at all. So you don't even if there's something in there, you don't know how much. So how can you conduct science with it?
It's very strange.
What? How do you explain that there's some people out there who claim that the virus has been isolated? I've listened to some of them trying to explain this to me, but I wasn't able to understand. Whereas when you're saying you were trying to get this, to find a specimen, and pretty much everything, you can buy, pretty much buy everything. But for this part for this coronavirus isolate, you kind of ran into a brick wall. How do you explain this? And how is the other side, not the other side, but how are some scientists, on what basis can they conclude that the virus has been isolated?
Well, I think it's an obfuscation of the terminology, because the CDC uses the term isolate to refer to any sample taken from a person who is declared to be symptomatic and declared to be carrying a certain disease. So in other words, one of these so-called isolates, which is not an isolate, was taken from a woman in Seattle, Washington, I believe in February of 2020. And this is one of the materials that's available for sale to laboratories. And essentially the history of this is they took a woman off an airplane who flew to Seattle from China. She was symptomatic. This was determined to have taken place during the time of this outbreak in China. And so it was simply declared that she had COVID. And then samples taken from her, which blood samples, and then serum samples derived from that, were then declared to be an isolate. And it's literally called an isolate, even though it is not isolated particles. Now, and the way this is very easy to confirm is I could buy one of these samples, I could put it under a scanning electron microscope, and I would see a lot of different things of all kinds of different shapes and sizes in human cells and different genetic material strands and so on. An isolate should be uniform. It should be all the same thing. When I buy an isolate of glyphosate, I can go onto chemspider.com. I can see the molecular structure there. If I were to put the glyphosate under a microscope, there would be nothing but glyphosate. All the same, all uniform. That's an isolate. If you look under a microscope and you see all kinds of random crazy things and some cells and some genetic material and maybe even some blood cells mixed in there as well, giants on the microscope, I'm sorry. That's not good science. That's not an isolate. How do you know what you have? And furthermore, how do you know how much you have? Now, and this gets to the PCR test. A PCR test claims to flag the presence of one or more strands of genetic material that is amplified. But they amplify it so much with the cycle thresholds that they're really amplifying background instrument noise. And what happens is they lose what we call in lab science the signal to noise ratio. Mm-hmm. You have to have a signal to noise ratio. So if I'm looking at, let's say, mercury, if I'm looking at mercury in a food sample and my background noise is like this, but the mercury is the same, the mercury peak, we would say, is the same height as all the other background noise peaks, you can't say you found mercury because it has to stand out. And in fact, for qualitative measurements, you have to have a signal to noise ratio of at least 3-to-1. And for quantitative measurements, you have to have at least 10-to-1. And none of that exists in these PCR tests with the high cycle thresholds. So there's my answer.
Why has the data not been shared?
No, they didn't isolate the virus.